A strange flash on a NASA live feed, a world-renowned physicist issues a cryptic warning, and suddenly, everything we thought we knew about the moon is wrong. For decades, whispers of odd signals and unexplained events have circulated, but now the data is undeniable. The moon isn't the dead, silent rock we imagined. It's active, it's unpredictable, and it might be far more dangerous than we're being told. As we race to build a permanent base on its surface, are we ignoring the signs? Let's delve into it. Historical context: Apollo's ringing bell. Here's where the story gets strange, and it starts with a sound that should have been impossible. Back on November 20th, 1969, the Apollo 12 crew intentionally crashed their lunar module ascent stage, Intrepid, back onto the moon. The 2.5-ton vehicle hit the surface at over 3,700 miles per hour, an impact equivalent to about 1 ton of TNT. Dr. Gary Latham, the lead investigator for the Apollo passive seismic experiment, was waiting for the data. On Earth, a similar impact would create a tremor lasting a few minutes. Instead, Latham and his team watched in disbelief as the moon vibrated, resonated, and rang like a colossal gong for 55 minutes. The seismic waves traveled through the entire lunar body, something that baffled geologists. Latham himself said the data was so strange they had to recheck their instruments. This single experiment shattered the idea of the moon as a simple, solid rock. It suggested something was fundamentally different about its internal structure, perhaps vast hollow spaces, or a fractured dry core that allowed vibrations to propagate without dampening. That ringing sound was the first hard data point showing the moon held deep, resonant secrets. AI surveillance systems. In the 21st century, we don't just rely on human eyes to watch the skies. Who's watching the moon when we aren't? The answer is artificial intelligence. Sophisticated AI systems now monitor continuous data streams from lunar orbiters, which have sent back over 1.4 petabytes of data. That's 1,400 terabytes. These neural networks, developed by scientists like Dr. Kiri L. Wagstaff at NASA's Jet Propulsion Laboratory, are trained on millions of high-resolution images to detect patterns and anomalies a human operator would almost certainly miss. Think of it as the ultimate security camera for our celestial neighbor, with a resolution capable of spotting objects as small as 50 centimeters. These systems aren't just looking for craters, they're hunting for outliers in thermal, spectral, and topographic data. They can distinguish between a 1-millisecond cosmic ray strike, a camera glitch, and a genuine surface phenomenon with over 98% accuracy. When an AI flags an event, like the one that triggered this warning, it's because the event breaks established patterns across multiple data types simultaneously, giving us a new, unbiased look at what's really happening up there. The moon is alive. Forget the image of the moon as a dead, static world. It's not. It's groaning, shrinking, and breaking apart, and we have the data to prove it. In 2023, India's Chandrayaan-3 mission deployed its seismometer, ILSA, near the South Pole. S. Somanath, the chairman of the Indian Space Research Organization, announced that in just 11 days, it detected around 250 seismic events. While many were linked to the rover's movements, dozens had no clear explanation. They were genuine moonquakes. This confirms what a team led by NASA planetary scientist Dr. Thomas Waters has been warning about for years. Using data from the LRO, his team has mapped thousands of fault scarps, which are cliff-like features that form as the moon's interior slowly cools and shrinks, causing the crust to fracture. Some of these scarps are over 100 meters high and can run for dozens of kilometers. They are geologically young, meaning the moon is actively shrinking and breaking right now. This creates shallow, potent quakes, some estimated to be as strong as a 5 on the Richter scale, concentrated right where NASA plans to build the Artemis base camp. Underground mysteries. If the surface is more active than we thought, what's happening underneath? The answer might be even more unsettling. Decades of data have pointed to the existence of enormous caverns beneath the lunar crust. These are not small caves, they are massive lava tubes. Planetary scientist Dr. Pascal Lee of the SETI Institute has studied these features as potential habitats because they offer incredible protection, reducing lethal radiation exposure by a factor of 1,000 or more, and providing a stable temperature of around -20 degrees Celsius, compared to the surface which swings from 120 degrees Celsius to -170. But their scale is, honestly, terrifying. Japan's Kaguya orbiter discovered a lava tube in the Marius Hills region that is estimated to be over 50 kilometers long and at least 1 kilometer wide, large enough to fit the entire city of Philadelphia inside it. NASA's Grail mission confirmed these massive hollow spaces stretch for miles. Here's the concerning part. These voids are concentrated in the same regions as the most intense seismic activity. Imagine building a habitat on what appears to be solid ground, only for a magnitude 5.5 moonquake to collapse the kilometer-wide cavern beneath you. The invisible killers. While the ground could collapse beneath our feet, a far deadlier threat is constantly bombarding the lunar surface from above. This danger is completely silent and invisible. The moon has no atmosphere and no global magnetic field to protect it from cosmic radiation. When the sun has a major eruption, like a coronal mass ejection or CME, it hurls billions of tons of charged particles into space at speeds exceeding 2,000 kilometers per second. These particle storms hit the moon with their full, unfiltered power. Dr. Janet Luhman, a senior fellow at the Space Sciences Laboratory at UC Berkeley, has spent her career studying these events. During a major solar storm, the radiation dose on the lunar surface can spike to over 100 sieverts per hour, a lethal dose for an unprotected astronaut. What's terrifying is how these events can appear on camera feeds. High-energy particles striking a camera's sensor create bright flashes and bizarre interference patterns, a visual signature that matches the recent anomaly. Solar Cycle 25 is proving to be far more active than predicted, with major solar flares happening 37% more often than in the previous cycle. The hidden race for control. While we debate these natural dangers, a more calculated threat is emerging. We are not the only ones with lunar ambitions anymore. The moon has become the focus of a new, high-stakes space race. NASA Administrator Bill Nelson has been very direct about this, stating publicly that the United States is in a space race with China, and that we should be concerned about them claiming lunar territory. NASA's Artemis program aims to land astronauts at the lunar South Pole by 2026 or 2027, but China's Chang'e program has already landed there with robotic missions and plans its own crewed landing by 2030. Both nations are targeting the same resource-rich regions, like the Shackleton crater, which is believed to hold over 500 million metric tons of water ice in its permanently shadowed regions. Whoever controls that water controls the future of deep space exploration. The recent anomaly was spotted in a strategically vital area, and with the U.S. Space Force now responsible for monitoring activity out to 22,000 miles and beyond, the question becomes strategic. Was it a natural event, or was it a piece of undeclared hardware from another nation? Historical patterns, transient lunar phenomena. Strange lights on the moon are not a new occurrence. For centuries, astronomers have documented what are known as transient lunar phenomena, or TLPs. These are short-lived changes in light or color on the lunar surface. On May 4, 1787, Sir William Herschel, the discoverer of Uranus, reported observing what he believed were 3 volcanoes erupting on the moon. In the 1960s, NASA commissioned a study which resulted in the technical report R277, a catalog compiled by astronomer Winifred Sawtelle Cameron listing 579 reliably observed lunar events. These sightings often cluster around specific geologically interesting regions like the crater Aristarchus, which is actually a hotspot for TLP reports. One leading theory, championed by planetary scientist Dr. Arlen Kratz, is that these flashes are caused by the release of ancient gases from below the surface, which kick up dust that reflects sunlight. During the Apollo 11 mission, Mission Control alerted the crew to a TLP report from German astronomers who had just observed a bright glow near that very crater. Apollo-era secrets. Let's go back to the Apollo missions because the astronauts saw things that were never fully explained to the public. The crew of Apollo 11 described seeing flashes and streaks of light, even with their eyes closed. But other sightings were external. Apollo 15 Commander David Scott logged a bright flash near the crater Grimaldi that Mission Control could not explain. Then there was the seismic data. It wasn't just the lunar module. NASA also crashed the 15-ton SRVB booster stages from Apollos 13, 14, 15 and 17 into the moon. Each time the moon rang for hours, sometimes up to 4 hours. Dr. Yoshio Nakamura of the University of Texas, who analyzed the complete set of Apollo seismic data for decades, concluded that the moon had a surprisingly light, porous and heavily fractured crust down to a significant depth. The seismic waves moved as if they were passing through a material unlike anything on Earth. Declassified documents also revealed that Cold War reconnaissance platforms, like the Vela satellites designed to detect nuclear tests, also captured brief, intense flashes from the moon that didn't correspond to any known meteorite impacts. Why it matters to you. This isn't just about strange lights 384,400 kilometers away, it's about the future of human exploration. We are returning to the moon, and this time, the plan is to stay. The Artemis program, with a projected cost of $93 billion through 2025, is a massive global investment in our multi-planetary future. The technologies we are developing, quake-resistant habitats, radiation shielding, closed-loop life support systems, are the same technologies that will one day take us to Mars. But as space policy expert Dr. Bhavya Lal has emphasized, the success of these missions depends on accurate risk assessment. What if that assessment is flawed? Building a base on ground that is unstable, riddled with voids, and blasted with radiation is a recipe for disaster. The investment is immense, but the potential return in scientific discovery, technological advancement, and securing humanity's future beyond Earth is incalculable. Getting the moon right is the critical first step. The terrifying reality. Let's put all the pieces together. The evidence, collected over 50 years, paints a disturbing picture. Apollo-era experiments from scientists like Gary Latham proved the moon has bizarre resonant properties. Modern seismometers confirm it's geologically active, with moonquakes up to magnitude 5 concentrated exactly where we plan to build. Planetary scientists like Thomas Waters have shown us the fault lines. We know from researchers like Junichi Haruyama that there are massive hollow lava tubes beneath the surface. Meanwhile, space weather experts like Janet Luhmann warn that the sun is entering a violent period, bombarding the moon with lethal radiation. On top of all this, as NASA Administrator Bill Nelson states, the moon is a contested territory in a new geopolitical space race. Each of these facts alone is a serious challenge. Together, they suggest the moon is a far more dangerous and unpredictable frontier than we have been led to believe. The anomaly on the live feed was the trigger that connects decades of unsettling data into one terrifying conclusion. The evidence is clear. The moon holds secrets we are only now beginning to unravel. The consistent pattern of anomalies from the Apollo era to today's AI-monitored feeds tells a story of a world that is active, complex, and potentially treacherous. As we prepare to send the next generation of explorers back to the lunar surface with the Artemis program, we must proceed with caution and a newfound respect for the challenges that await. The stakes, human lives, national investment, and our future in space, are simply too high to ignore the warnings. If you found this exploration as fascinating as we did, don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our universe. What do you think the moon is trying to tell us? Thank you for watching Stellar Tech.